Okay, thank you all. It is now truly a privilege to welcome, to conclude the course, a seminar by John McNeill. He is the Distinguished University Professor at Georgetown University, where he has spent the bulk of his career. He has had as eminent a career as a historian can have. He is a leader in the field in every way, intellectually, but also serving the organizations that keep our field going, the American Society for Environmental History. He was president as well as of the American Historical Association. He's a member of the American Academy of Arts and Sciences and the Academia Europea. His work is among the most important and, to me, inspiring work in the field. He is prolific, and I won't give you the titles of all of his books, but he has written about everything from the mountains of the Mediterranean to the environmental history of the 20th century. And that latter particularly is found in a number of articles, but two important books, one written with Peter Engelke, The Great Acceleration, that I showed in my lecture, and another that complements it very well. If you're interested, I highly recommend his other book, Something New Under the Sun, An Environmental History of the 20th Century World. He's worked as well on a book that I know almost by heart, Mosquito Empires, Ecology and War in the Greater Caribbean, on the environment and health history of the Caribbean in early modern times. He also wrote with his father one of my favorite overviews of human history, The Human Web, A Bird's Eye View of World History. He's an environmental historian who helped create the field and who continues with his work to be a leader. I will tell you, he is for me truly a model and an inspiration. And I will say, in moments when I sometimes get a little bit depressed about the state of academic history and the possibilities thereof, John is someone who I think of in order to keep me going. He really is an inspiration for what is possible as a historian. So it's really personally very meaningful that he has accepted to come across the ocean. His leadership and involvement in the Anthropocene question, as a historian who's been concretely involved in this conversation, is hugely important, and it's very timely. And so I think this is a very important stage and opportunity for him to participate and to help us participate in this conversation about what the Anthropocene means, where it is, and where it might be going. So what a privilege and opportunity. Please join me in giving a very warm Collège de France welcome to John McNeill.
Merci beaucoup, Kyle. Malheureusement, ça fait longtemps que je n'ai pas parlé français et alors je m'excuse de parler anglais. So this lecture is intended to follow upon the one that Professor Harper just gave, and I will speak about the Anthropocene and an allied concept, the Great Acceleration. And I'll try to explain the justification for these concepts. And I will review some of the debates and disagreements surrounding, in particular, the concept of the Anthropocene. I do this partly as a historian, but also as a member of something called the Anthropocene Working Group. The Anthropocene Working Group was 37 scientists and scholars, most of them geologists, who for 15 years have been trying to amass the evidence for or against the concept of the Anthropocene as an official interval of time in the geological timescale. Earlier this week, the Anthropocene Working Group was dissolved. So we no longer exist officially. So Professor Harper explains some aspects of the concept of the Anthropocene. This is a general overview. It is, geologically speaking, a proposed revision to the geological timescale, one that approximately 10 days ago was formally rejected by the Subcommission on Quaternary Stratigraphy. Stratigraphy is the science within geology that pays attention to the strata, the layers of rock and sediment and ice. And the Subcommission on Quaternary Stratigraphy pays attention to the last 2.7 million years, the Quaternary or Quaternary era. And that subcommission voted against the concept of the Anthropocene by a margin of 12 against and 4 in favor. And that vote was then confirmed by a higher body within the International Union of the Geological Sciences. So temporarily, the Anthropocene is dead as a formalized unit of geological time. But the Anthropocene is also the recognition that the Earth system, the Earth operating system, all the biogeochemical cycles that regulate the Earth are operating differently now than they have done during the Holocene. The Holocene is the last 11,700 years. Officially, we're still in the Holocene. The Anthropocene is also the recognition that it is primarily human activity that is responsible for the fact that the Earth system is no longer operating the way that it did for the last 11,700 years. And it's also the recognition that there are in the rocks and sediments good markers that indicate before and after, before the advent of the Anthropocene and after the advent of the Anthropocene. And that these markers will endure for thousands and in cases for millions of years. That's what I understand the Anthropocene to mean. In the last 10 years or so, the word has become routine, and its meaning has become looser and more variable, and different people use it to mean different things. And most of the scholars who use the term Anthropocene come from literature and philosophy, not from the natural sciences, not from geology, and not from history. And they use it often to mean one of these three things: the current environmental crisis, or current climate change, or even more loosely still, nowadays. This image, by the way, this is artificially generated There is a sign that looks a great deal like this outside of the city of Las Vegas, the gambling capital of the United States, which says, "Welcome to fabulous Las Vegas." So somebody changed this to the Anthropocene era, not recognizing that the Anthropocene is proposed as an epoch, which is shorter than an era. Not so important. This is what the International Geological Timescale looks like, and if the Anthropocene were adopted, it would appear right here. This is the most recent moment, and here's the quaternary or quaternary, these last 2.7 million years. And the older eras of time, way back to 4.5 billion years ago. So this is what the International Union of the Geological Sciences controls, and this is what it has this month declined to change. I disagree with that decision. I was among those members of the Anthropocene Working Group who favored the formal adoption of the Anthropocene for reasons that I will begin to explain to you now. So the Anthropocene Working Group made an official case that the best marker for the beginning of the Anthropocene lies in the sediments of this lake just west of Toronto, Canada. This is a lake that has annual sediments, which makes a very good archive of biological and geological and geochemical change through time. It's like having an archive without rats and mice in it. It's like having an archive without politicians who steal documents. It's a wonderful natural archive. I'm not sure if France has politicians that steal documents, but in the United States we do. So Crawford Lake is a very small lake. Here is one of the cores taken from its sediments, and you can actually see the annual layers in the bottom of the lake. And right around 1950 or so, the strata change, and they begin to include much larger quantities of plutonium. They are recording the beginning of nuclear testing, especially hydrogen bombs. The argument that the Anthropocene's best marker is in Lake Crawford, and the argument that around 1950 is the best birthday for the Anthropocene, doesn't mean that the Anthropocene was caused by plutonium or caused by nuclear testing. All it means is that's the best marker. Other things that I'll refer to in a moment, I maintain, are better causes of the Anthropocene. Here are some of the additional places around the world where there are very good markers. There's, I think, 10 or 12 of these that the Anthropocene Working Group considered in detail before deciding that Crawford Lake was the best. The second best is here in Manchuria, Sihailongguan Mar. And so that's officially proposed and rejected as an alternate GSSP. I should explain, GSSP, Global Stratigraphic Section and Point. This is not fully a requirement, but it is a desideratum for stratigraphy. Some sort of marker in sediments or rock or ice that shows before and after. And this is an example from Japan of a GSSP that marks the beginning of an interval of geological time called the Chibanian. And nobody cares about the Chibanian. It's not controversial at all, but it was officially ratified by the International Union of the Geological Sciences about 3 years ago. So I'm going to shift for a moment and talk about a different but related concept, the Great Acceleration. Because it is, in my view, the Great Acceleration that is responsible for creating the Anthropocene. By Great Acceleration, I mean, and others who use it mean, a change beginning in the 1950s and running through the 1960s and 70s at least, and maybe beyond that, in which an enormous expansion of various forces changing global ecology. And I list some of them here: water use, energy use, the size of the economy as measured by GDP, the size of the human population, the quantities of fertilizer in use, the amounts of paper produced, and so on and so forth. And the big point here is that if you aggregate all these measures, it's in the 1950s that the slope turns sharply upward. And this is why I call it the Great Acceleration. These are socioeconomic driving forces. This chart is direct indicators of global environmental change, several of which I mention here. Ocean acidification, which is this big orange band in the middle, which very interestingly shifts from basically zero in the 1840s to much higher levels. This represents the onset of intensive coal use, primarily in Great Britain. Because it is through the burning of coal and the release of sulfur dioxide and carbon dioxide into the atmosphere that the oceans have acquired, since 1840, so much additional acid, approximately 30% more than in 1840, which, when you consider how large the oceans are, is quite a large-scale change. But again, if you accept ocean acidification, most of the other indicators show a sharp upturn in their intensity, magnitude, starting in the 1950s. Here are the same data arranged differently, and Professor Harper showed this image as well. The previous ones aggregate the data differently and don't have a specific y-axis or vertical axis. But here, each of these has its own, not that you can read it, mind you, each of these has its own units on the vertical axis. By the way, are all these slides going to be made available to anybody who wants them? Yeah, okay. These will be available to you in case you want to study the details. So these graphs are often referred to as the Great Acceleration graphs. Now I'm going to focus in on a few components of this era of spectacular global environmental change. And first, biodiversity. So for 20 years or so, specialists have been making the argument that we are in the early stages of a sixth great extinction event. There have been 5 big ones in the history of life on Earth. Big ones are defined as having 75% reduction in the total number of species. Now, in 2024, we aren't anywhere close to that, but the rate of species extinction has climbed extremely dramatically in the last century or two. This chart looks only at mammals, vertebrates of all kinds, including birds and mammals. But if you include insects, if you include mollusks, probably the scale of extinction in the last century, and especially the last 40 or 50 years, is even greater. It's harder to count small things like insects, so we really don't know for sure, but the specialists who do this have concluded that. So there is a realistic chance that we are at the beginning of a sixth mass extinction, which would leave a permanent record in the strata of the Earth, a fossil record. Second, water. Here again, the point of inflection in the middle of the 20th century is visible. These are total global freshwater withdrawals, which means extracting fresh water from rivers and lakes and streams, mainly for use in agriculture. And part of the reason behind this upsurge in water use is the technology available for creating big irrigation dams and hydroelectric dams and multi-purpose dams, which developed primarily in the 1930s and 40s and reached a peak in 1968. That was the year when the largest number of big dams, 15 meters or taller, was created. Thirdly, the atmosphere. And Professor Harper showed you this curve as well, the so-called Keeling curve. And just to be clear, the annual ups and downs are just seasonal changes that reflect the growing season in the northern or the southern hemisphere. At any rate, this is the record taken by measurements in Hawaii since 1957. And in some respects, it's a discouraging one because all the international politics trying to address climate change appear to have had no impact. Although conceivably the slope of the curve could have been steeper still without the efforts that have been made. Here's a much longer view from ice cores as well as from, since 1957, the direct measurements made in Hawaii. And this longer view, since 1700, allows you to see, again, the significance of the middle of the 20th century in changing the slope of this curve of carbon dioxide concentrations in the atmosphere. For the entire Holocene, the last 12,000 years, carbon dioxide concentrations have been within a band between 280 and 260 parts per million, with modest fluctuations. But they escaped that band in the 19th century and then took off in the middle of the 20th century. Here's the very long term, 800,000 years of carbon dioxide concentrations. So this goes back way before the Holocene into the Pleistocene. And here, the variations have been greater between 180 and 280 parts per million. And this is almost certainly true back 2.5 million years. We don't have an ice record before 800,000 years ago, but there are other ways to try to judge the amount of carbon dioxide in the atmosphere from soil carbonates. And these go back 2.5 million years. And they show the same thing, fluctuations between 180 and 280 parts per million. But then, starting in the middle of the 20th century, breaking out dramatically from that band at a rate of change entirely unprecedented, and 100 times the rate of change of the last glaciation and the last deglaciation as well. So the scale and the pace of carbon dioxide accumulation in the atmosphere, especially since about 1950, is without precedent in the last 2.5 million years. And probably since the Miocene, maybe 12, 15 million years ago. Fourth, energy. Energy is what I regard, and Professor Harper also considers energy very important, what I regard as the single most important explanation behind the Great Acceleration and the Anthropocene. And here again, in the middle of the 20th century, you can see a change in the slope of the curve, sharply inclining upwards. Most of the reason for that is the advent of oil, and secondarily, natural gas, new fossil fuels on top of the prior fossil fuel regime based on coal. And according to one of the members of the Anthropocene Working Group, Jaya Savitsky, humankind has used more energy since 1950 than in the 11,700 years of the Holocene prior to 1950. And I think she's probably correct in that calculation. So this is why I regard energy as at the core of the explanation for the Anthropocene and the Great Acceleration. Population growth is also significant, although I would argue less significant than the energy system that we built in the 20th century. So this shows you both the total number of humans up through 2023. This, the lighter green, is projection, and the projection may or may not be accurate. but up to 2023 and 8 billion humans. These are reliable data. And you can see again that the middle of the 20th century was a turning point in the long-term, 320-year history of human population. The thinner curve, this one here, is the rate of population growth. And here it's the 1940s when this, late 1940s, when this really begins to accelerate. Incidentally, this sharp dip is the so-called Great Leap Forward in modern Chinese history, an effort by Mao Zedong to industrialize China overnight that contributed to a large-scale famine. So before I get into the debates surrounding the legitimacy of the Anthropocene, I want to summarize the differences between the Great Acceleration and the Anthropocene and try to sharpen the distinction between the two concepts. So, in my judgment, they both begin at the middle of the 20th century. But the Great Acceleration has begun to end. I wouldn't say that it's genuinely ended yet, but it's ending. The pace of population growth has slowed dramatically. Not only have we passed peak child, as Professor Harper showed you, but just look at the descent in the rate of population growth in the last 3 decades. It's falling just about as fast as it rose in the late 20th, or mid to late 20th century. The energy intensity of the global economy has begun to decline. That is, the amount of energy required for each unit of economic production. The total energy use has begun to stabilize and looks like it is set to decline. Total freshwater use has stabilized, may or may not be set to decline. But a number of the important driving forces and indicators of the Great Acceleration are stabilizing. So I think there's every prospect that in the next decade or 2 or 3, all those curves that I show you will level off and stabilize. And the Great Acceleration will be over. The Anthropocene, on the other hand, even though the geologists have formally rejected it, I maintain is here to stay for tens of thousands and probably millions of years. The indications of it, such as changed chemical composition of the atmosphere, are extremely unlikely to undo themselves within centuries or even millennia. And we have almost certainly postponed the next glaciation cycle in the history of the Earth by at least 500,000 years and probably by 500,000 years. That's a gigantic change in future Earth history for which our energy system is primarily responsible. The new sea level in my lifetime has increased by about this much on average around the world. By the end of the 21st century, the average guess, the middle scenario, is by about this much. The new sea levels, which may be much higher than that, 5 meters, 10 meters, 15 meters above present sea levels, are sure to endure for many, many thousands of years, probably at least 200,000 years. And that's because the heat that is now accumulating in the oceans has nowhere else to go. It's going to stay in the oceans. The oceans will continue to expand spatially. The acidification of the ocean is also impossible to reduce in short order, or it's extremely difficult and unlikely that anything could reduce it in short order. And the coral reefs, which depend on a certain level of acidity, I think it's around 8.2 on the acidity scale. The coral reefs are disappearing all around the world, as you probably know, and to judge by prior episodes in which coral reefs disappeared and then were reconstituted, it takes millions of years for that cycle to play itself out. So it will probably be millions of years again before coral reefs return to something like the condition of 1980 or 1950. And there are all sorts of new strata in the rock that are going to endure for millions of years. The Paris metro system's tunnels, which were begun, I think, at the end of the 19th century, they may not survive as metro tunnels. They may cave in, but they'll be distinctive geological strata for millions of years. There will be plastics in the Earth's strata for thousands of years, possibly longer than that. It's not entirely clear how slowly some plastic compounds degrade. And of course, all the species that have gone extinct lately and all those that are going to go extinct in the near future, they will never return, and they will leave a permanent fossil record as long as the Earth remains. So that's why I say the Anthropocene is set to endure for tens of thousands, probably hundreds of thousands, maybe millions of years. But of course, something else could happen. An asteroid could hit the Earth, as a big one did 66 million years ago, and create yet a new interval of geological time. Eventually, something like that is sure to happen. But for now, and probably for many thousand years, I say the Anthropocene is with us. So, some of the debates. As Professor Harper mentioned, the term was launched in 2000, although the concept without the term had existed previously. There were scientists thinking about the role of humankind in changing the face of the Earth back into the 19th and even the very late 18th century. In fact, the Comte de Buffon, not far from here, was among the first to think in those terms. It looks to me that the popularity of the concept of the Anthropocene is unusual in the history of science, and analogous perhaps, it's too soon to say, I admit, to some of the other big ideas in science that took a few decades to establish themselves, such as plate tectonics, which was first published as an idea about 1915 and formally accepted by the majority of geologists in the 1960s. So it took 40 or 50 years for that idea to catch on. Or the idea of evolution through natural selection, which also took several decades before the majority of scientists accepted it, and the majority of human beings still do not accept it. This is very similar to an image that Professor Harper showed you about the uptake of the idea of the Anthropocene, especially since 2010. And these are in books only, not articles. The majority of these books are written by people in literature and philosophy, as I mentioned before. Now, some of the objections to the word, less so to the concept. That will come next. The prefix anthropo, according to some critics, assigns responsibility for the changes that make up the Anthropocene to all of humankind. That's the critique. And that, of course, would be a gross distortion of the historical facts, because some people are far more responsible for all the changes to the Earth systems than others. The average Mozambican peasant has had almost zero impact on the Earth's operating systems, whereas someone like myself, who flies across the Atlantic in order to speak to you at the Collège de France, has considerably more impact. And according to a study done by a colleague in Austria, Roman Abramovich, I think his name is, the owner of the London football club Arsenal and a Russian oligarch, he has the world's largest impact on Earth systems because he flies around the world in his own jet all the time. He has about 20,000 times the impact that I have. He also maintains 7 or 8 homes and so forth. So that's the first objection about the prefix and what it seems to imply about responsibility. Now, geologists say the prefix doesn't say anything about responsibility. The prefixes for all the other intervals of time in Earth history mean nothing. The Jurassic, which is named after the French-Swiss mountain chain, the Jura, it doesn't mean the Jura Mountains caused or are responsible for this interval of geological time. No. All it means is it's in the Jura Mountains that scientists found the sharpest indicator, the best golden spike between the time before the Jurassic and the time of the Jurassic. At any rate, it's probably too late to change the term Anthropocene to Crawfordocene. Some other objections are that using the term and the concept of Anthropocene weakens the political constituencies for biological conservation and indeed for caution with respect to the human presence on the Earth. By that I mean, it weakens the cautions against geoengineering, on the grounds that if the Earth is already a humanized artifact, if the Anthropocene is with us already, well, why not consciously manage the Earth through geoengineering so as to achieve an optimal Earth? Now, for me, as a historian, I'm a connoisseur of unintended consequences, and geoengineering frightens me. It's impossible to do only what one intends the first time around when playing with large, complex systems. So I am firmly opposed to geoengineering, although I should say Paul Crutzen, for a while, was in favor of it, although he did change his mind. Objections within geology now to the formalization of the concept. Some geologists say, and I understand the logic of this argument, that it's too soon to pass judgment and to accept the Anthropocene as a unit of geological time because it's only approximately 70 years old. So let's wait 10,000 years or a million years and then decide. And some geologists say the Anthropocene is not useful within geology. And the whole point of dividing up Earth history into all these units of time is to be useful, is to make it easier for us to talk about and think about Earth history. And the Anthropocene is too short to be useful, some say. And it's not scientific enough. It's driven by political considerations, some say. And then some, including the Secretary General of the International Union of the Geological Sciences, say that the concept is illegitimate because there are members of the Anthropocene Working Group who are not geologists. And there are. There are two historians. There's, I think, two archaeologists, one lawyer, and there used to be a journalist before he quit, and a couple others. But it's about 80% geologists and stratigraphers, that subset of geology that I referred to before. And related to this objection is the notion that the idea itself was first advanced not by a geologist, by an atmospheric chemist, Paul Crutzen. I think none of these objections carry enough weight, particularly the last one. If a good idea comes from outside of one's own academic or scientific discipline, that is no reason to discard it, but such things do happen. The Anthropocene does have political ramifications, implications. That does not make it bad science. The idea of evolution through natural selection, which is good science, was very politically controversial and remains politically controversial, not least in the state where Professor Harper comes from. Professor Harper mentioned some of the debates about the onset of the Anthropocene. So as you know, I'm among those who support the notion of a mid-20th century birthday for the Anthropocene. Others, maybe 8,000 years ago, that would be William Ruderman, whose position Professor Harper explained. Others say 1492 because it was the unification of the hitherto separate worlds of the Americas and Afro-Eurasia that should be recognized as the major transition. I think the evidence for that proposition is extremely poor. Paul Crutzen originally said the Industrial Revolution is the key turning point, and at times he would specify 1783 because that was the date in which James Watt improved steam engines significantly, or maybe 1784. I think it was 1783, though. Part of these arguments depend on which kind of evidence one prefers, and that usually depends on which academic or scientific discipline one has been trained in. So for Paul Crutzen, atmospheric chemistry was where we should look for evidence about the advent or the birthday or the beginning of the Anthropocene. For paleontologists, and there is one on the Anthropocene Working Group, it is the fossil record where we should look for evidence concerning the beginning of the Anthropocene. So a large part of the quarrel is just based on how we are socialized into science and the academic world. Unfortunately, in stratigraphy, there has to be one golden spike, one birthday for the Anthropocene. We can't have a gradual onset of the Anthropocene, even if that seems to correspond to the way historians, such as myself, might think about it. So, I'm coming to my conclusion now. As I said before, and as Professor Harper alluded to, earlier this month, officially, the International Union of the Geological Sciences rejected the proposal from the Anthropocene Working Group that the Anthropocene should be adopted and formalized. So that's not happening. So where does the Anthropocene stand? The first thing I would say is that because it is not going to be formalized, it's going to get more confusing as a concept, because more and more people will use it to mean more and more different things. And if I'm right about that, it means the usefulness of the term is going to decline. It's already a bit fuzzy. I think it's going to get fuzzier. The International Union for the Geological Sciences is talking about trying to ban the use of the term in the official publications of the International Union of the Geological Sciences and at the annual meetings of the IUGS. I don't think they're going to do that. I think that would be too Stalinist an approach to science for them, but who knows? We will see in the next month or two. The geologists are now, in effect and inadvertently, inviting other sciences, other kinds of scholars to pursue their own agendas within the concept of the Anthropocene. So I think what's going to happen is more and more Anthropocene discourse that is focused on issues that geologists don't care about. Issues such as causation, issues such as ethics, issues such as values, and inevitably politics. By making the Anthropocene a forbidden concept, so to speak, within geology, the geologists are surrendering Anthropocene discourse to everybody else. So I wrote this slide up about 2 or 3 days ago, and I said the Anthropocene Working Group will be disbanded. Well, it happened yesterday. We weren't told about it. It's just that the website of the IUGS obliterated all reference to the Anthropocene Working Group and the Anthropocene and all the data that my colleagues had prepared. So the Anthropocene Working Group is no more officially, but the 37 scientists and scholars in that group, I'm sure, are going to continue to work. They have been working this week, generating new papers, new data in support of the concept of the Anthropocene. And I also think that eventually the Anthropocene will be formalized. It might take 50 years, it might take 80 years. Some previous intervals of geological time have taken that long to be adopted officially. But it could happen in 10 years, because the current leadership of the International Union of the Geological Sciences and the current membership of the voting body, the Subcommission on Quaternary Stratigraphy, they're going to change. And when new people come in, the issue could be revisited and a different result perhaps expected. This week, the Anthropocene Working Group produced a new paper with yet more graphs like that and yet more graphs like this. And in closing, let me say that in addition to continuing its work, the Anthropocene Working Group, it seems to me, has begun to seek to outmaneuver the bureaucracy of geology by appealing to the media and the public with its arguments, which is very difficult for geologists and stratigraphers to do, because their language is a very difficult and jargon-filled, technical, scientific language. So explaining themselves to a general audience is not easy for them. And they're also beginning to look for stronger alliances outside of geology, but within natural science. All of which is intended to change the result sooner rather than later and win formalization for the concept of the Anthropocene. So, as I see it, formalization of the Anthropocene is indefinitely postponed, but it might not be long, maybe a decade or so. Meanwhile, the concept of the Anthropocene is going to get less precise, more vague and confusing, and therefore less useful, which might work against formalization in the longer run. The concept of the Great Acceleration, it seems to me, is tighter, clearer, because it's less controversial and less in use. So for the time being, that might be an easier concept to work with. At any rate, that's the way I see it. Thank you very much for your patience, and thanks to the Collège de France and to Professor Harper for this opportunity to share my views with you.